today's show is going to be on the Doppler effect. Let us see who sent in our question for the day. And let's hope we can get this right. So yes, today's concept is on Doppler, and we see that we've got a resident learner and we get the questions in from Zoegle High School, and it's always great to hear from you. So let us have a look. It's on Doppler, and Doppler, the question is quite a small question. It's not normally for many marks. It's normally between, I would say, about 8 to 10 marks, but it's really a question that you can actually score easy marks on it. All right, so let us have a look at the actual question. Right, so question 1 says, a patrol car is moving at a constant speed towards a stationary observer. The driver switches on the siren of the car when it's about 300 meters away from the observer. The observer records the detected frequency of the sound waves of the siren as the patrol car is approaching, as it passes, and then moves away from him. The information is given on the graph below. Now I would like you, if you can, just to take a photo of the actual graph. So there's the graphs. I want you to notice, so that was the initial. Let me just select my pen here with everything. I haven't selected my pen. So I see it's 932 Hertz. They haven't given me this frequency here, so obviously that is one that I'm going to have to calculate. And I see that at 10 seconds something happened, that the frequency actually dropped. All right, so let's just go back to the actual question. And it says, take the speed of sound at 340 meters per second. All right, sorry about that. So now, first question, calculate the speed of the patrol car. Now, what information did they give me? They told me we were working at a constant speed. So when it's with a constant speed, we know it's not accelerating. They've given me the displacement, and the displacement is the distance is 300 meters. So let's make a note. We've got acceleration is 0. We've got displacement equal to 300 meters, and they are asking us to calculate the initial velocity. And what did they give us from the graph? I notice on the graph we've got 10 seconds. So the time that he did this was in 10 seconds. So now you're going to go to your information sheet, and we're going to use an equation of motion. So if we have a look at our equations of motion, here they are over here. Let me just take a different color pen. All right, so here are the equations of motion. So I could use one of those, or I could use one of these equations. So the question is asking for the initial velocity. So each of these contain initial velocity. All right. But I notice this contains final velocity. I don't have it. This contains final velocity as well as this one. So my instinct is telling me this is the equation to use, because I've got the displacement, initial velocity they're asking, and the time was given to me. And what do we know about the acceleration? The acceleration was 0. All right, so let's go back to our question. So I need to change my color pen quickly. All right, so let us have a look. So now we're going to write out our equation of motion. So we're going to go delta x equals vi delta t plus a half a delta t squared. So delta x was 300 meters. V initial I'm wanting, it was in 10 seconds, plus a half times a was 0 because it was constant, and delta t was 10 squared. So if we go into the calculation, we get 300 equals 10 times v initial. So now I see v initial equals 30 meters per second. Now they're asking me speed, so I don't need to give a direction. And there we go. Now the next question normally with these would be to give the definition. So it's a very commonly asked definition. So please go and study your definitions. All right. So your Doppler effect, let's just have a look if that was the next question. I'm just preempting here. All right. So let's have a look. And there it is. So state the Doppler effect. Now these normally are 2 marks or 0. So please make sure you study those definitions that you can get full marks. Now, because of all the time issues, I'm not going to go through the Doppler because I'm sure you know the Doppler effect and you've been studying your definitions really, really hard. All right, so please don't forget to study those definitions. All right, let's look at the next question. Now, the next question says, the detected frequency suddenly changes at t equal to 10 seconds. Give a reason for this change. So normally with the Doppler effect, we find that as a siren or as the source, the sound source is approaching us, we find that the frequency increases. The reason for that is because you've got more waves striking our eardrum and we hear this at a higher frequency or a higher pitch. As it passes past us, what happens now? That pitch decreases. So the frequency decreases. So now as it's past us, we have less waves striking our eardrum, so we hear it at a lower pitch. All right, so what happened at t equal to 10 seconds? The car was moving away from us. All right, so what happened here? You can just say the car was moving away. And that is why we had the drop in frequency. All right, now we need to get on to the big calculation. All right, and here it comes. It says calculate the frequency emitted by the siren, and there it is for 4 marks. All right, so let us go to our information sheet once again. And we have a look at under wave, sound and light. And let me just change my color pen, and here it is here. So that is the expression that you're going to use. So FL is the frequency of the listener. V is just the speed of sound. VL is the velocity of the listener, divided by V plus or minus V source, the velocity of the source. So S stands for source, L stands for listener, multiplied by the frequency of the source. Okay, so we've got to now go and copy down our expression, and then we just substitute into it and we solve. All right, so let's have a look. So we're going to write down our equation. So our equation, oh, let me change my color pen again, sorry. And let's get rid of this. All right, so there we go. So the frequency of the listener is equal to V plus or minus the velocity of the listener divided by V plus or minus velocity of the source multiplied by the frequency of the source. So now let us try and substitute into that. So the frequency of the listener, we're going to get that off the graph. So remember, they gave that to us as 932. So that was the detected frequency. That is what the listener is hearing it, and they are hearing it at 932 hertz. So we substitute in. They told us that we must take the speed of sound at 340, so we substitute in for 340. The listener was standing still, so we're going to leave that out. And then we're going to have 340. What was happening? The source was coming towards us, and the speed of that vehicle was, we calculated it to be 30 as it was moving towards us, multiplied by the frequency of the source. And now we can just solve for frequency of the source. So we're going to go 932 multiplied by 310 is equal to 340 frequency of the source. So the frequency of the source is equal to 932 multiplied by 310 divided by 340. And all we need to do is put it into our calculator quickly. So we've got 932 multiplied by 310, and that is equal to 288, 920 divided by 340, and that should give us our frequency, and there it is. So the frequency is equal to 849, and I lost the decimals. Let's just get the decimal. So it's 849,76, 76 hertz. And there we go.